This talk is called Wranglers of the Lost App, some field notes from a PaaS to an AWS migration. And because we're in Indiana, I took inspiration from the greatest adventure of them all, Indiana Jones. I am MK Barton. I'm a co-founder of Rootwork Labs, boutique consultancy working with DevX, DevOps, and data engineering, as well as some security stuff. My partner, Ian, designed all these great looking slides, and AI actually made me look really handsome in that picture there, so that looks great. So our plan for today is we're going to start with expedition prep. How do we get ready for this? We're going to survey the site, we're going to establish a base camp, then we're going to rescue that idol, and we're going to put it in a museum and show everyone what we did. Expedition prep. So a bit of historical research about what brought us here. Oops, sorry. So Platforms as a Service is a service that can abstract away some of the infrastructure management. It can abstract away servers, networking, container orchestration, and more. Things like Heroku, Vercel. And these services are great for a number of things. An early team that's just starting to ship features and you don't want to hire an expensive infrastructure team, or you don't want to deal with the DevOps guy who's telling you that you're doing it wrong. And you want to get your market fit established quickly. But PaaS can also obscure scaling behavior, container restarts, deployment traceability, and some cost ownership. So why was my client looking to do this migration now? First of all, it was around business growth. There'd been a dramatic increase in the amount of users, and we had seasonal scaling requirements. This was an ed tech company, so whenever the school year started, whenever there were exams, or whenever the students were panicking, we needed to scale up. Secondly, we had some increased operational complexity. More services, more deployments, more overhead, and the changes needed to be discoverable, repeatable, and reviewable. And the team had grown as well. It scaled from 2 engineers to 15 engineers. And infrastructure ownership was becoming a team concern, not an individual concern. And within this, it's one thing to manage permissions if you have 2 engineers, because I know who to blame if someone did something wrong. But if it's 15 of us, it's a little bit harder. And lastly, observability. Configuration obscured some of the container restarts and made some of the problems difficult to identify. We had resource pressure that we couldn't trace to what was causing what to happen. Now, one thing I want to mention about this client is they had run on this PaaS provider for 4 years. The abstractions were a feature right up until the minute that they stopped being a feature. It allowed them to do exactly what they wanted to do, which was prove product market fit, scale, and get started. It took them from nothing, I'm talking $0, 2 people, to a profitable business. The need to migrate was not a result of failure in the PaaS business, but of its incredible success. So I don't want anyone to take away from this talk that, I think PaaS is bad. PaaS is great. It can be a great solution for what you're using. So let's get out into the field and survey the site. So we're going to grab our brush and our notebook and start looking around. So the first thing when we're surveying a site is we want to use the right tools. And what's the best tool when you're surveying something? A map. A lot of times we don't have a map, so we need to create one. And what we did in this case was use infrastructure as code. So what that is, if you're not familiar, it's using code to provision your infrastructure rather than doing ClickOps at the console. You can check it into GitHub, you can do pull requests, and you have a history of what you've done. And in this stage, it's important to remember, we were just importing the existing infrastructure. There were some servers out there, there was a network out there, we're going to go ahead and import that just so we have a sense of what's going on. And tread lightly on the precarious terrain. Things like networks, security groups, route tables, IAM. That can be where you discover some problems that you need to address. And at this point, you need to be cautious, like Professor Indy here. Focus on understanding, not solving the problem. What are your pain points? What capabilities are you trying to add? And if you don't know what those are, if something isn't obvious, maybe you don't need to migrate. That's great. You can just keep doing what you're doing. So we've made our map. We're going out into the field, and we're going to establish base camp. The first thing we discovered was that our PaaS provider had built their solution within the default VPC, the virtual private cloud. Again, if you're not familiar, it's a private network within AWS that is kind of like a private data center in the cloud itself. And the default one is great for getting started, but it can be a little too permissive. It can cause some problems down the road. So the first question we asked is, should we build our solution inside the default VPC? And the answer was clear. No, we should not. Why not? Well, we wanted to build a parallel VPC so that we could have safety and security and freedom to experiment. So our idea was to build a VPC right next to the existing one, and it would allow us to build, tear down, experiment freely without impacting production. It allows us to start completely from scratch and avoid problems like overly permissive security groups, of which there were a couple. And it's completely isolated. It avoids breaking the existing system. Like, I started looking at this going, what happens if I remove this entry from this security group in the default VPC? And the answer was, I don't know. So let's not do it. So this is how the system looked at this point in the process, as we had our default VPC with our production services, our databases, our CI/CD pipeline, and our staging services. And we set up a new VPC, same account right next to it. Now, there were a few things that I was making up as I went along. I built environment-specific subnets, which was kind of a mistake. I built public and private for staging. I built public and private for production. For a future data team, I built public and private for them. And it really added far too much complexity too quickly. At this point in the migration, public and private per availability zones, that would have been sufficient for what we needed. And the point here is that even seasoned adventurers can make mistakes and only add complexity when it becomes obvious that you need to. And finally, understand what you're doing before you start solving it. That will get you out of making it up as you go. So throughout this talk, we're going to have a few things called these professor's notebooks, which are stuff I found along the way that I thought were useful and that I wanted to share, but didn't kind of fit into the overall narrative. So the first one is AWS tags. AWS tags are great. You can tag any resource, any policy, pretty much anything within AWS you can tag. And the first thing I discovered is any consistent tag taxonomy is better than no tags. If it's consistent and it's bad, that's better than no tags. However, inconsistent tag taxonomy is worse than no tags at all. So what we used was Terraform variable validation to enforce tags. Kind of similar to the last talk, we wanted to make sure tags all fit the same framework, the same structure. So we settled on a pretty simple taxonomy. What environment are we in? What service is this? And most importantly is who owns this. And this will become more important down the road. In this case, the owner could have been either the PaaS provider or my client. So we're working on our base camp and we're going to start building a staging environment. And the important thing to realize is you are building it for yourself, not for the developers. Plan the staging environment that mirrors what you're doing in your PaaS provider, but build it with your target architecture. Now, I'm not going to go into the specifics. There'll be a few references to the architecture we decided on, but this isn't a talk about pick this thing because it's the best thing to do, because quite frankly, I don't know what the best thing to do is in your case. So build it with your target architecture, and it's for your use and discovery. You can use it, for example, the first thing you should do is troubleshoot your network configurations. Are your security groups set up? Can you follow a request all the way through the chain? Does it get to the database? So here, we've added our staging services. We have a staging environment that's totally isolated. I've got a staging database over in my other VPC. I can do whatever I want. I can drop the database. No one cares. I mean, I would care, but. So another professor's notebook around security groups. Has anyone ever struggled with naming security groups, or is that just a me thing? I've tried a couple different things. I've tried describing what they do. Allow the application load balancer to reach the service. Okay, that sounds good. does that security group go on the load balancer or does it go on the service? Because we're describing two different things. Okay, that didn't work. So I'm going to describe what they are. I'm going to allow traffic on port 8000. Cool. That's great if you know that your Django application is running on port 8000, which sure, in this case I did. But what if it's running on a non-standard port, or something else is running on a non-standard port, or you don't have all the default ports memorized? It doesn't really tell you a whole lot. And after making a ton of mistakes, I settled on naming them for where they are in the network. This is in the staging environment, it's on the application load balancer, and it's a security group. This is a production environment, it's on the service, say the API service, and it's a security group. So now we're going to improve staging, and this is for the developers, not for you. You'll start by dual deploying both to your PaaS environment and to your new staging environment. This gives you opportunity to identify bugs and misconfigurations. At this point, it's a good idea to start introducing your team if they're not familiar with infrastructure as code. This is a good point to start doing that. And you want to make it easy to correct misconfigurations. What I found in this migration was the thing that caused us the most problems. We're getting environment variable values correct. So we've got staging, we've got our map, we're ready. We're going to go rescue the idol now. And this is not to be taken lightly, as Marcus Brody says. So, step one, let's create that production environment. Fortunately, with infrastructure as code, it's easy to mirror what you just did in staging, configuring it now for production. And you want to deploy to both the PaaS environment and the new environment. So you're going to be deploying to two production environments. However, don't send any traffic to that new environment yet. That's the important part. This is a rehearsal process. This is to see where the tech debt is in your CI/CD pipeline. In this client's case, they had some real observability problems around what was happening when our code was being deployed. And I didn't want to replace one obscure system with another obscure system. And in my opinion, yes, DevOps dude, of course I'm going to say this, but you don't want to leave tech debt in your pipeline for this at this point. You've got a chance to get it right. Take the time and get it right. And again, I'm going to say this a lot, test every link in the network. Can that service find the database? Can it find elastic cache? Can the internet reach it? So now we have our production service and our staging service, a CI/CD pipeline, but we're isolated from each other. And I didn't want to move the production database at the same time I moved to a new environment. That seemed like too much risk to do at once. So I had to reach from the new custom VPC to the default VPC. And there is a mechanism for this. It's called VPC pairing, or peering, sorry, not pairing, peering. And this allows you to reach from one VPC to the other using route tables and security groups. So at this point in the project, this is the first time that anything I'm working on in my custom VPC can reach anything in the old VPC. So we talked about environment variables and how easy it is to misconfigure those. This is a little something I found that the team adopted pretty quickly, and I thought it worked really well. So this is some Terraform code here. We put all the environment variables into a single file called env_vars.tf, and we used the locals and the subkey feature in Terraform. So this would be locals.common environment variables. Where do those environment variables go? Well, they're common to all the services. And we use this as an opportunity to encourage learning on the parts of the devs. I was working with a team that was not comfortable with IAC, so this was really their first encounter with it. And when we found problems, I encouraged them to change the value, submit a pull request. Next deploy, we'll hit it. You don't want to do this with secrets, though. Secrets you want to handle differently. Don't check your secrets in. These are non-sensitive environment variables. And for our configuration, this is a simplified version of our Django service. This is all the implementation is for getting all those environment variables into your service. And the actual list was about 85. So putting all 85 in here would have been a mess, and it would have made it difficult for the developers who are already like, what's this IAC stuff? to work with. When it's a simple key value pair, it gets them contributing earlier and quicker. So we're rescuing the idle, and Sala is asking us, Indy, why is the environment moving? And the environment's not literally moving, but you should treat it as a hostile creature. This environment that you built, it will turn on you if you let it. Anything that can go wrong will go wrong. Anything that you don't know that can go wrong, that's also going to go wrong. You have to leave yourself an escape route. And how do you do that? If there's nothing else to take from this, it's to understand that your migration, they're all various versions of failure until they're not. Give yourself an escape route. So our escape route was DNS waiting in Route 53. So we used waits in the Route 53 record to say 99.9% goes to the old environment, 0.1% goes to the new. When you get to this point, your stakeholders have to be informed. And that does not mean your boss. Let them know, whatever, that's fine. But the people I'm talking about here are customer success, customer service, the people on the front lines. They're the ones whose lives get miserable if you mess up. They're the ones fielding the calls, working the tickets. You need to tell them in advance what's going on, and you need to tell them what you're doing while you're doing it. You need to tell them what to expect. And you need to tell them that you will roll back the traffic because you will not get it right the first time. So now we have our full diagram here. We have our Jeep with some internet traffic. That's all of you. It's going through our Route 53, and we're sending 99.9% of you over to the left and 0.1% over to the right. I guess that's reversed. Anyway, sorry about that. So this is live footage for me switching the traffic from one service to another. I was a lot handsomer in that picture. And this is live footage of customer success watching me switching that traffic over, hoping for the best. So an important professor's notebook at this point is your logging situation. This is a question you need to be able to answer. Can I tell exactly which deployment produced this specific log entry? Could someone else tell that? With no context, at 3 a.m. when they're on call. And you need to do whatever you can to get that answer to yes. This is foundational. We cannot be trying to figure out and divine what log entry came from what environment. This has to be clear. And sometimes I feel like logs don't get the love and attention that they should. For us, the solution was actually pretty simple. We had some log forwarding lambdas that shipped the logs off to Datadog. And we included, an environment and a service. And in this case, like the service would be called Django Fargate, as opposed to Django Docker Swarm. So one of my developers could be like, is this production? Yes. Is this the Fargate deployment? Yes. What time did this happen? It's right there. And the service and the environment variables, those just get passed in via Lambda. So you can set up multiple ones. So now we're rescuing the idle, and it's not the years, boy. It's the traffic. So send a bit of traffic, identify the bugs, fix the bugs, send more traffic. Repeat that process until you have about a 50-50 split. Most of the bugs have been squashed, looking good. Your next instinct is going to be to continue. Fight that instinct. Do not continue. Stop everything. Let the system sit for a couple of days, because not every problem is going to show up immediately. There might be that one job that runs at 7 p.m. on Sunday, but only when it's a leap year, and that problem is going to show up on Sunday when it's a leap year. A note here, your costs are going to go up, and you need to be prepared for that. However, if you used AWS tags well, you can identify and, more importantly, explain which costs belong to which environment and which costs you expect to go away once the migration is complete. And once the traffic is switched over, you might think you're done. You're not done. A whole bunch of problems come rolling after you. Memory leaks, DB connection spamming, tasks that have been silently failing all along. This is stuff we didn't know about. Now we have a whole host of new problems to fix. But that's actually the good news, because you can fix them. So we've identified these problems, we're fixing them. It's time to put this in a museum and share it with the team and the outcome and the learnings. So first thing is, we do not want the top men ending from Indiana Jones, from Raiders of the Lost Ark. We are not putting this in a box in a warehouse somewhere that no one ever refers to. We're not going to do that. Instead, we're going to put this in a museum. So here's our findings from this migration. First one is business growth. Remember our panicked students who were putting load on our system at random times because they forgot to study? Well, scaling is now trivial. We have Fargate auto-scaling groups that go up and down as we have demand. We were able to launch specialized containers for different tasks rather than running all of our celery tasks through the same size container. We could pick different ones. This one needs more memory. That one needs more CPU. Let's split out our migrations and run those separately. Operational complexity. Deployments became immutable, and they were traceable back to the merge PR. Previous to this, we were deploying latest. Never deploy latest when it's a Docker container. That's always a bad idea. But we could now see what's running in production, where was that merge in GitHub, and who did it, and who can we blame for the problem. We added health checks and automated rollback. Prior to this, a problem in production meant you had to revert the entire merge and redeploy. Here we could just roll back, fix the problem without causing downtime. This supported the team growth. And one of the coolest things out of it was it allowed the creation of PR environments, which were on-demand environments that matched staging and production. And infrastructure as code made this trivial to implement. And strangely, I became one of the biggest users of these PR environments because I could try out new infrastructure without wrecking anything. Finally, and most importantly, observability. Memory leaks became obvious. Failed tasks became obvious. Noisy neighbor problems became obvious and then were disappeared because we were isolating the services. The first one here, we fixed the memory leaks. You can see we did 3 changes on one day, and you can see when each one was deployed. And going forward, we had a much smoother resource utilization. And this memory leak was also causing us additional costs because we were running at like 8% CPU and maxing out our memory. Our deployment cadence improved. Pre-migration, it was maybe 1 a week. Post-migration, we got up to about 5, which is excellent. Releases became smaller, safer, and easier to repeat. Our async task failures went from pretty bad to getting better. We're still working on these. But we really didn't have any observability into where and why they were failing. Lastly, this one. Man, we discovered this. Whew, we were spamming our DB like crazy. And this was causing all kinds of, they're related problems, but it showed up in like tasks that ran out of memory, or the response time from Django was just off the charts. And a lot of it was related to this spamming of DB connections. And once we migrated, you can see how clean it gets. We saw the spamming and we're like, oh, okay. This fix, by the way, 1 value in an environment variable. That was it. So I really want to thank you all for going on this expedition with us. And I'm missing you already. Okay, we're just about on time. I'm not keeping everyone from lunch. But if there are any questions, please feel free to ask. Or you can visit us at rootwork.dev or give me an email. But again, thank you so much. Any questions? Yeah, the question is, did Terraform, was that the prime way we were able to improve our observability? And that was a big part of it because we knew exactly what was being specified. The infrastructure we were migrating from was a Docker swarm, and it was shared across, I think, about 6 or 7 EC2 instances. And what we ended up finding is there was constant container churn that we were unaware of. And that container churn, like the problems were there, but the container churn obscured what was causing it. And with Terraform, like each one of these was a separate Fargate service. It's like, Django is having a bad day. Let's go find out why. All righty. Well, thank you so much. I really appreciate you all coming out. Thank you.